The other day, I came across a series of sentencing reports from a court in China. On the surface, it looked like a standard criminal proceeding, but the atmosphere described was anything but ordinary. Several individuals were being handed down heavy prison sentences, not for moving illicit drugs or stolen data, but for something far more primitive: bags of dull, grayish minerals. To a casual observer, these were just rocks. But to the global economy, these men were smuggling the most critical currency of the 21st century. The scene shifts from that quiet, cold courtroom to the frantic boardrooms of Western semiconductor giants and defense contractors. For years, the prevailing logic in Silicon Valley and Washington was that they held all the cards because they owned the brains, the high-end chip designs, and the sophisticated software. They assumed the body, the raw materials, would always be available, a mere commodity to be bought and sold. But on December 18th, that assumption hit a titanium-reinforced wall. What is striking isn't just the policy shift, but the calculated, almost surgical nature of the move. China didn't just issue a statement. They tightened a localized grip on the very elements, gallium, germanium, and antimony, that make modern warfare and AI possible. It is a classic asymmetric strike. While the West continues to build walls around technology, China has decided to control the very ground that technology is built upon. There is a certain irony in watching this play out. One moment, the global supply chain is a seamless, invisible machine. The next, a few license requirements in Beijing send costs skyrocketing for a fighter jet manufacturer half a world away. It's a high-stakes game of resources for technology, and the rules just changed overnight. The question is no longer who can design the fastest chip, but who is even allowed to have the dirt required to build it. As those smugglers discovered, the price of that dirt has become immeasurable, and the tech blockade has officially met its match in the Earth itself. Okay, so let's really unpack this. That introduction, it lays out what is, a fundamental reversal of the global economic logic that we've all operated on for decades.
It really is.
Yeah.
For so long, the West, primarily the U.S., controlled the brains.
The chips, the software, all the IP.
Exactly.
Right.
And China was seen as, well, the supplier of the body, the raw earth, the assembly lines.
And that assumption is what has just been completely shattered. What we're diving into today isn't just another trade dispute. This feels different. It's an asymmetric resource strike.
That's the perfect term for it. It's using geological dominance to directly counter technological restrictions. And what's so fascinating is how calculated and surgical it is.
Surgical is the right word.
It's not a blanket ban. They're targeting these very specific dual-use materials.
What do you mean by dual use exactly?
Elements that are essential for both advanced commercial tech, think AI chips, fiber optics, and at the same time, modern defense systems. We're talking advanced radar, guidance systems, that kind of thing.
So by hitting these materials, you hit two critical sectors at once.
You hit commercial innovation and you hit national security. It gives them maximum leverage. It elevates these minerals from just a commodity to a genuine geopolitical weapon.
Okay, so before we get into the strategy behind it all, we really have to get a handle on the scale of this mineral arsenal. What are we actually talking about here?
Well, the first strike targeted gallium, germanium, and antimony. Then it expanded to include what we call rare earth elements, or REEs.
And these aren't things you can just swap out for, say, aluminum or copper, right?
Oh, not at all. They are functionally essential. Take gallium. It's the foundation for gallium nitride.
Which is used for what? High-power chips?
High-power, high-frequency chips. So 5G components, military radar, the kind of tech that lets an F-35 see with incredible precision. Without it, modern defense capability just degrades.
Okay, and what about germanium?
Germanium is absolutely vital for fiber optic cables, the backbone of the internet, and also for things like space-based solar arrays.
So no germanium, no internet as we know it, and space exploration gets a lot harder.
You're starting to see the picture. And then you have antimony, which is a key component in specialty alloys for advanced weapons. So each one is a choke point.
And the dominance, the numbers I've seen are just, they're hard to wrap your head around. Can you just run through them for us?
Yeah, they really demonstrate a near monopoly that, frankly, the West just allowed to develop. For gallium, China accounts for 98% of the world's primary supply.
98? That's not a market. That's a switch you can flip.
It is. And the U.S. doesn't even produce primary gallium anymore. For germanium, it's around 60% of global production.
Still a huge majority.
And then you get to rare earths, and it's even more layered. China handles about 69% of the mining, but the crucial part is the processing. They control up to 90% of the refining capacity.
And that's where the real value is, in the processing.
Absolutely. And for the most critical subset, The heavy REEs, things like dysprosium and terbium, which you need for high-performance motors that run hot.
Like in missiles or EVs.
Precisely. For those, China controls an astonishing 99% of the refining capacity.
99%. So when one country controls the tap for the material that runs stealth jets and the entire green energy transition, it's not a commodity anymore.
No, it's a strategic asset.
Yeah.
And the key insight, the real aha moment here, is that it's the processing dominance, the know-how, that's the impenetrable layer of control. They own the entire technology stack to turn dirt into a high-purity functional component.
Which is a perfect segue into our next theme, the ground war. This isn't just about digging stuff up. It's waged through bureaucracy, regulation, and a very deliberate internal narrative.
Exactly. You have to understand how this is viewed from inside China to see the whole picture.
Right. I was reading about this compliance officer, a guy named Lao Chen in Ximen. And for years, his job was just to watch raw ores, like germanium and gallium, get loaded onto ships like they were common gravel.
For pennies on the dollar, I imagine.
Literally. Sold for a pittance, only to come back months later as these incredibly expensive high-tech sensors and optical equipment that China had to buy back at, 20 times the price.
Exporting the future and importing it back in a plastic case.
That's almost exactly what he said. But now, his job has completely changed. He's not just weighing things, he's scrutinizing end-user certificates, checking quotas. He described it as long overdue stewardship.
And that's the critical narrative. This isn't framed as an export squeeze to hurt rivals. It's about being responsible guardians of the nation's technological vitamins, as he called them.
So it's about stopping that race to the bottom in mineral pricing.
Yes, exactly. The argument is, we're not going to trade our geological wealth and our environment for minimal profit anymore. We're going to ensure these resources are used sustainably and strategically. And this whole idea of stewardship is backed by a really formidable legal and bureaucratic machine.
They weaponized their legal system.
They did. The restrictions are all justified on national security grounds. They just point to the dual-use nature of the materials. If you can go in a phone and also in a fighter jet, well, then it's a regulated strategic asset.
And the rollout of these controls, it wasn't random, was it? It felt very deliberate, almost like a series of tests.
Oh, completely calculated. It started in July 2023 with the first licensing requirements for gallium and germanium. That was the testing ground.
And it worked.
It worked perfectly.
Yeah.
Exports of those minerals to the U.S. just dried up. So they knew the mechanism was effective.
Yeah, and they expanded it.
Right. October 2023, they added graphite to the list. Now they're signaling they can target the EV industry, the whole clean energy transition.
And then came the big one, December 2024.
That was the escalation. An immediate, explicit export ban on gallium, germanium, and antimony aimed squarely at the U.S.
A direct response to the U.S. semiconductor restrictions.
A clear tit for tat. They made it absolutely clear. You hit our tech, we hit the earth your tech is built on. Then in April 2025, they did it again, this time with 7 key rare earths dysprosium, terbium, right after the U.S. announced new tariffs.
So for a foreign company, this creates what you call the licensing labyrinth. It's not always an outright ban, but it's death by paperwork.
It's death by 1,000 cuts. They have this one batch, one license system. Imagine you're running a factory. Every single shipment you need, no matter how small, requires a separate approval.
And that takes how long?
Officially, it's 45 to 60 working days.
Yeah.
So 2 to 3 months of lead time just for a signature. But in practice,
It's much longer.
much longer. Companies report it can stretch to 6 months or more, especially if tensions are high. And for a just-in-time manufacturing world, a 3-month uncertainty window is basically a death sentence.
And the paperwork itself is a nightmare, I understand. They want to know everything.
Everything. It's not just who's the buyer. They demand commercially sensitive details. Things like proprietary blend ratios, your production volumes, who your end customers are.
So they're essentially using compliance forms to conduct industrial espionage.
It's pure intelligence gathering via bureaucracy. You apply for some gallium, and you might as well be handing over your entire business plan for the next 5 years.
That's a huge competitive advantage.
It's massive. And on top of that, you have technical glitches in the system that seem almost designed to create chaos.
You're talking about the HS code problem.
Exactly. The harmonized system code is how goods are classified for trade. The problem is, all permanent rare earth magnets, whether they contain the restricted stuff or not, share the same HS code.
So even if your product is totally legitimate.
It gets flagged. A shipment of a common non-restricted magnet can be held up for weeks for scrutiny over trace impurities. It's an incredibly effective non-tariff barrier. The red tape itself becomes the weapon.
So the bureaucracy is one layer, but the real advantage, as you said, is the know-how, the alchemy. This brings us to the industrial alchemist.
Yes, this is about the shift from digging dirt to mastering the science of refining it.
I was reading about this material scientist, Dr. Zhang, in Jiangxi province. He's been in the industry for decades, and he talked about this huge psychological shift from being the world's quarry to becoming its alchemist.
I love that framing. It's so telling.
For years, his lab just focused on basic extraction, selling the raw output for cheap, knowing the real value is being added in labs in Japan or the US. He said it was deeply frustrating.
And now?
Now his team holds patents on the world's most advanced solvent extraction tech. They're hitting purity levels nobody else can. He said resource sovereignty isn't about owning the dirt, it's about owning the knowledge to perfect it.
That sentiment, that pride, it captures decades of successful, deliberate industrial policy. Before 2000, China exported over 90% of its rare earth output.
Just shipping the raw stuff out.
Exactly. By 2012, they were exporting less than 20%. They successfully transitioned. They started consuming it internally to build sophisticated downstream products and then exporting those.
And the key to that was this massive push for vertical integration, mine-to-magnet supply chain that no one else can match.
No one. They control the mining, the processing, and this is the critical part. 85 to 90% of the production of high-strength rare earth magnets.
The things you need for every EV motor, every wind turbine, every smart bomb.
And it's all policy-driven. Their tax code, for example, gives a 13% VAT rebate on finished magnets you export. But if you export the raw concentrate...
Zero rebate.
Zero. They built the entire economic architecture to keep the high-value work at home.
Which leads to what I think is the most dangerous part of this whole equation, the monopoly on the manufacturing equipment itself.
This is the checkmate move, in my opinion.
China has banned the export of the processing equipment related to rare earths.
Right. So even if you find a big deposit of rare earths in, say, Australia or Canada, that's great. But how are you going to process it? You need the machines. And you can't buy them.
For 20 years, the West has been completely dependent on Chinese engineers, Chinese manuals, Chinese spare parts.
I heard a story about a new facility in the UK. An engineer there was describing their spin caster.
That's the machine that turns the molten alloy into the little slugs for magnets, right?
Yeah.
It's a critical step.
Absolutely critical. And he said, the interior is Chinese, the exterior Japanese.
Yeah.
A frank admission that the core technology, the part that actually does the work, was all from China.
And now that door is shut. I read about USA Rare Earth Inc. trying to set up in Oklahoma. They're facing years of delays because they can't import the machines. They have to design them from scratch.
And that's a huge expensive lag. You're talking hundreds of millions of dollars in years of R&D just to get back to where your competitor was a decade ago.
But why is it so hard? I mean, the US, Germany,
Yeah.
they can build jet engines and supercomputers. Why can't they build a furnace?
It's a generational gap in expertise. It really is. The West just doesn't have a critical mass of metallurgical engineers who know how to do this anymore. The experts from the 70s and 80s, when the U.S. led this field, they're all retired.
So the tribal knowledge is gone.
It's gone.
Yeah.
And we've seen the cost of that ignorance. Multiple big solvent extraction plants built in the West have failed catastrophically in the last decade.
Because the chemistry is just so corrosive.
Incredibly corrosive. Pipes burst, vessels collapsed. They only got these plants working by flying in Chinese engineers who had already solved these problems dozens of times. That safety valve is now gone.
So they have the materials, the machines, the processing knowledge, and the people. And on top of all that, they're patenting the future.
They're locking it down. They view their lead in innovation as a strategic weapon. By 2018, Chinese entities held almost 26,000 REE patents.
How does that compare to the U.S.?
More than double the U.S. total of around 9,800, and more than Japan and the EU combined. And what's really telling is that over half of those patents were filed after 2011. The acceleration is clear.
And this is most visible in green tech, where the whole world is trying to compete.
Yes. The NdFeB magnets are the unsung heroes of the clean energy economy. China produced 240,000 tons of them in 2023. That's 85 to 90% of global output.
And the first big new U.S. plant?
MP Materials, slated for 2025, its projected capacity is 1,000 tons a year.
1,000 versus 240,000? That puts the challenge in pretty stark perspective.
It's a chasm. And Chinese firms are already innovating on the next generation, finding ways to use less of the scarcest rare earths, like dysprosium. This lowers their costs and secures their advantage for decades to come.
So when a move this complex is executed, the global fallout is, well, it's immediate and it's severe. Let's look at the actual consequences, starting with that industrial crisis after the April 2025 controls.
The effects were instant and they were painful. A lot of companies, despite the warnings, were still running on lean, just-in-time principles. They didn't have the stockpiles to ride out a 3-month delay.
And the numbers are just eye-watering. By May 2025, just weeks later, magnet shipments to top customers they fell off a cliff.
They did. Down 77% to the US, 55% to Germany, 81% to South Korea. It was a near total industrial halt for major economies.
And this engineered scarcity just sent prices into the stratosphere.
Absolutely. In European and US markets, the shock was profound. Bismuth up 22% in a week. Dysprosium and terbium prices more than doubled. Yttrium went up 6-fold. A price shock like that can just wipe out your entire business model overnight.
And we saw that ripple right through to the auto industry.
Instantly. Ford suspended operations at its Chicago plant. Suzuki halted production of the Swift in Japan. It shows how fast a supply chain dependency becomes a real-world production loss.
In the case of Germany, it's just a stunning example of this exposed dependency.
It's incredible. In 2024, over 65% of Germany's rare earth imports and 92% of its permanent magnet imports came from China.
92%.
To put that in perspective, that reliance is actually worse than their dependence on Russian natural gas before the Ukraine war.
Wow. And that was considered a massive national security vulnerability.
Right. So if Russian gas was the benchmark for strategic risk, Germany is in an even deeper crisis now with the foundational materials for its entire future industrial base.
And it's not just the big names like BMW and VW, is it?
No, they were hit. But it's the smaller, specialized manufacturers who were hit the hardest. The ones making niche components for robotics or high-end machinery. They don't have the leverage or the stockpiles. For them, a 60-day delay means a complete shutdown.
Which brings us back to the defense choke point. This isn't just about cars and phones. This is about national security.
Fundamentally, modern militaries are built on these materials. We have the data for U.S. platforms. An F-35 jet needs about 920 pounds of REEs.
920 pounds?
An Aegis destroyer needs over 5,000 pounds. A Virginia-class submarine, over 9,000 pounds of rare earths.
So every major defense contractor for a U.S. rival is ultimately dependent on a supply line controlled by Beijing. That is a choke point.
It is. And Chinese regulators lean on that leverage. They demand exhaustive documentation to ensure minerals aren't being diverted to military end use in the West. That bureaucracy slows everything down, drives up costs, and injects huge uncertainty into defense procurement.
In a global game with stakes this high, you're going to see responses. The chessboard is shifting. Let's talk about the diplomatic maneuvering that happened right after the crisis hit.
Right. After the industrial fallout got really bad, a temporary trade truce was reached in May 2025. A bit of de-escalation.
But the key word there is selective, right? China started easing restrictions, but not for everyone.
Not at all. It was very selective licensing. Some civilian firms, like Volkswagen, which has huge joint ventures in China, were among the first to get their licenses approved.
A diplomatic concession to a key partner like Germany.
Exactly. Ease the pressure just enough. But critically, there was no recovery for the most valuable heavy REEs, like dysprosium. That tap stayed shut. And the bureaucratic backlog is still immense. 500,000 German export license applications were reportedly still pending.
So they keep the pain on, but just below the level of total crisis to maintain maximum leverage. And while that's happening, a new industrial geography is starting to emerge, with Southeast Asia as a kind of buffer zone.
This is a really interesting development.
Yeah, I was following this supply chain strategist, Sarah, based in Penang, Malaysia, the Silicon Valley of the East. Her company was getting hammered by the chip war, but recently she's been talking about this new resilient corridor.
What's the idea there?
It's a partnership. China provides the upstream mineral processing know-how, and hubs like Malaysia and Singapore provide the neutral, high-efficiency manufacturing ground away from the direct line of fire of U.S. tariffs or Chinese export controls.
That makes a lot of strategic sense. You use China's unique refining strengths, but you diversify the final manufacturing step.
And Malaysia has a huge new card to play. They just discovered massive RE reserves of their own.
An estimated 16.2 million metric tons. That gives them incredible leverage.
It puts them right at the negotiating table. China has already offered to help them develop processing tech, but with a catch.
What's the catch? The cooperation is limited to state-owned companies only. They're citing technology protection. They'll help secure the materials, but they won't let their proprietary know-how leak to a Western partner through Malaysia.
So Malaysia's now playing this very delicate diplomatic game stuck between the U.S. and China.
Exactly. They're promising equal and non-discriminatory policies to both sides. It's turning Southeast Asia into this crucial zone where companies might be able to get what they need without relying directly on the most volatile trade routes.
Meanwhile, the West is just mobilizing unprecedented amounts of money to try and catch up.
The scale of investment is huge. In the U.S., you have the CHIPS and Science Act. Over $52 billion for domestic manufacturing. And crucially, if you take that money, you're banned from expanding your high-end manufacturing in China for 10 years.
And the Pentagon is getting directly involved.
Right. The DoD has invested $400 million into MP Materials, the California miner, to secure rare earths at guaranteed prices just for the defense industry, creating a small but secure domestic supply line.
And Europe is doing something similar?
Yes, the European Chips Act is mobilizing 43 billion euros. And the Critical Raw Materials Act sets these really ambitious targets to source and process more minerals within the EU by 2030.
But is all this money enough? I mean, what's the real challenge here? It's not just about opening a few mines, is it?
No, that's the crucial point. The challenge isn't just replacing Chinese supply. It's about developing an entire parallel ecosystem of extraction, processing, and manufacturing know-how.
So you need to build the labs, train the engineers.
You need to build a DARPA for metallurgical engineering, a focused, heavily funded effort to literally reinvent the lost expertise. You have to design the spin casters and the furnaces from scratch. You can't just buy that knowledge off the shelf.
And while the governments are trying to do that, corporations are changing how they operate right now.
They have to. They're treating these components as strategic lifeblood. The old just-in-time model is dead.
So what's replacing it?
Stronger integration. Companies are co-designing chips with foundries now. That's why Apple has its M series, why Amazon has Graviton. It's about controlling your own destiny.
And diversification. No more single sourcing.
Single sourcing is seen as an existential risk, and companies are building up huge inventory stockpiles as an insurance policy. Toyota's 6-month chip stockpile used to seem crazy and inefficient. Now it's the industry benchmark.
So to kind of bring this all together, what we've seen is China's resource controls evolving into this incredibly sophisticated geopolitical tool.
It's flexible, it's scalable, and it's highly targeted. It blends legal, bureaucratic, and technical power. And the risk for the West is now deeply structural. It's not just about industrial competitiveness, it's about fundamental national defense capability.
And the crisis showed that even the biggest, most well-prepared companies could be brought to their knees in weeks by a single licensing change in Beijing. It proved that it's not about who has the dirt.
It's about who knows how to refine it. The world isn't in a trade war over metals, it's in a technology war over how to make them useful. China still holds the machines, the manuals, and the engineers, and until the West can recreate that entire ecosystem of expertise, any new project is vulnerable.
What we are seeing is the true price of industrial sovereignty. It's a price we used to think was just for oil and gas, but now it applies to the very earth we need to build the future. It's a reminder that control of the ground beneath our feet is, at the end of the day, the ultimate source of power in the 21st century.